So it says find the volume of the solid. Yesterday we talked about volume of prisms and cylinders. What was the volume formula for prisms and cylinders?
Area of the base times height of the prism.
Area of the base times the height of the prism. Good. What I'm going to write the rest of the class period at least, volume equals, this capital B represents area of the base, and then H represents the height. This is how it's written on your reference sheet, the reference sheet you're allowed to use on the quiz and test. It will not say prism formula, it's just going to say this formula. You'll need to know to apply it to a prism and a cylinder. So let's go ahead and take our highlighters and highlight the bases. What shape are the bases? Triangles, and they are on the front and the back. So 2 triangles. So we're going to go ahead and find the height because the height is what pushes those 2 triangles apart. So what is the distance between the 2 triangles? 3. Yep. 3. Good. Now we're going to find the area of the base. What shape is the base? We highlighted triangles. They're triangles.
Yeah,
right?
they're triangles.
Triangles. So remember that there are 2 of them. Okay, front and back. What is the area formula for a triangle? 1/2 base times height. What is the base of this triangle? 5 centimeters. And then the height is 8 centimeters. 5 times 8 is 40. Half of 40 is 20. Do I circle this answer? No, what do I do with it? Plug it in. The area of the base is 20 times the height of the whole shape, which is 3. 20 times 3 is 16. We say centimeters cubed. Good. Questions on this first one? Okay. Second, what is the shape of our bases? Trapezoids. What part of this figure are the trapezoids? Top, bottom, left, right, front, back. Front and back. Let's go ahead and highlight them. So same formula as in volume equals area of the base times the height. So what is the height of this prism? What separates the 2 trapezoids? 4.2. So it has to separate the 2 bases. All right, and then we're going to find the area. I'll show you what 2.5 is. We're going to do the area. We said the area, the shape is a trapezoid. So what is the area formula for a trapezoid? Times the height.
A equals.
So, thank you, Reagan. We got it. The 2 bases, what do I know about the 2 bases? What do they have to be? Nope. Parallel. Good. Of the whole figure, the bases are congruent. But when we're talking about the trapezoid itself, the 2 bases are parallel. So in our trapezoid, we're only looking at what I shaded in blue. What are the 2 bases? 4.4 and 5.6. And then times the height of the trapezoid. And it's what pushes the bases apart. Pushes the bases of the trapezoid apart. Yeah, that's correct. I wasn't saying you were wrong. Okay, it is 2.5. Okay, you're going to add inside of the parentheses first. 1/2. 4.4 plus 5.6 is? 10. Drop down that 2.5. Honestly, I would do 1/2 of 10, which is 5, and then I would multiply times 2.5. So what do we get? 12.5. Good. So this is the area of the base. So what do I do with the area of the base? Plug it in, multiply it times the height. So correct, 52.5, and it is meters cubed. Perfect. You can set that paper aside, and we'll go to page 3 of the notes. So, yesterday you were given a picture and you had to find the volume. Today, I'm going to give you the volume and you'll have to find parts of the shape. So, heights, radii, or lengths, width, things like that. So, you need to remember the formula. And for almost every single one of these, the easiest thing to do is to plug in the generic area formula instead of just writing the area of the base. So here's what that means. If you had a rectangular prism, in a rectangular prism, what is the shape of the base? A rectangle. What is the area formula for that base? Length times width. So instead of saying area of the base times the height, you would say length times width times the height. So you would do this for all cases except for when it says find the area of the base. And I'm going to show you an example. We're going to do 4 examples actually. Okay, so let's start with volume is the area of the base times the height. We're just starting from here and working our way out. It says find the indicated measure. We're going to find the height of a cylinder. And you can take your highlighter. It's important to know we have a cylinder with a base radius of 8 inches. So we have a radius of 8. Go ahead and highlight that as well. And a volume of 2,010 cubic inches. So before we begin, it's easier if you plug in the formula for the base, the area of the base. So what shape base does a cylinder have?
Circular.
A circular one, yep. So what is the area formula for a circle? Pi squared. So instead of saying area of the base, we are going to plug in the formula, which is pi r squared. All right, and then keep the height. All we have done is plug in the formula. Instead of saying area of the base, we plugged in the area formula for the base. So now we can just plug things in. All right, what is the volume? 2010. And it equals pi times, what is the radius? 8 squared. And then times the height, which we don't know. What is pi and 8 squared and h? What are they all doing to each other? They're all multiplying. So let's go ahead and multiply. All right, so I'm going to write this up here. 2010 equals, what is, even though you're using a scientific calculator, you should be typing in 3.14. So 3.14 times, what's 8 squared? 64. 3.14 times 64 is 200.96, and then the h just stays right next to it. So all we did was multiply pi, 3.14, times 8 squared. So what is 200.96 doing to the height? Multiplying. So the opposite of multiplying is dividing. So divide both sides by 200.96. All right, and then the height is 10. And it would be, this is a length, so it's 10 inches. So 9 times out of 10, you'll want to plug in the base formula. But in an example like the next one, we are going to find the area of the base and go and highlight of a pentagonal prism. So we got a pentagonal prism. So what shape is the base there? A pentagon, 5 sides. With a volume of 50. Go and highlight volume of 50. And a height, what's our height? 7.5. So we're going to use the volume formula. Volume equals area of the base times the height of the prism. Good. So in this case, first off, we don't have an area formula. At least you and I do not have an area formula for pentagonal base anyways. But because it said find the area of the base, leaving this like this, what does this capital B represent? The area of the base. So I would just leave the B as the B. We can plug in other things. So what is the volume? It is 50. Equals the area of the base, which we don't know, but we're hoping to find, times the height of the whole prism, which is 7.5. So what do I do to find the area of the base? Divide by 7.5. So the area of the base is
6.6
7,
yeah.
right? And then it is centimeters cubed. Oh, yep, squared. You're right. So why is it squared, not cubed? It's area. I'm sorry. So it was the area of the base as squared. All right. When you're ready, you can go ahead and turn to the next page. Were there any things I need to clarify? Okay. We just practiced it again. We just have pictures this time. So we're finding a missing dimension of a prism or a cylinder. We're going to do the same thing. We're going to use the volume formula. Volume equals area of the base times the height. What shape is this first one? What kind of prism? Rectangular prism. So when in a rectangular prism, any of the opposite sides could be listed as our base. So which one do we want to call our base? Top, bottom, left, right, front, back. Top, bottom, sounds good. So the top, go ahead and highlight the top. And I can only see this portion of the bottom, so. So in these, it is easiest when you plug in the base formula. We're not finding the area of the base. We're finding a very specific measurement. So what is the area formula for a rectangular base? Length times width. Good. So instead of writing B for area of the base, we're writing in the area of the base formula. And we're keeping the height. If it bothers you, this could be a capital. I don't know. It bothers me. So now we plug in. What is the volume?
661.5.
Good. 661.5. What is the length of my base? 18. So it's going to be 18 times the width of my base, which is
3.5.
it's y. And then my height of my prism is what pushes the two rectangular bases apart, 3.5. You would have still gotten the answer correct if you had mismatched, because this is rectangular and you end up multiplying all these numbers. So go ahead and multiply 18 times 3.5 while I drop down the left side. What is 18 times 3.5? 63. And then we still have the y. So how do I get y by itself? Divide by 63. And y equals 10.5. This was a length. So is it going to be centimeters, centimeters squared, or centimeters cubed? Centimeters. Good. It is a length. All right, this next shape, what are the shape of my bases? Circles. It's a cylinder. Go ahead and highlight them.
Wait, it wouldn't be centimeters squared or cubed?
It's not area. That's when you square. And then volume is cubed. So a length like this would not be. All right, so I'm just going to reference this. I'm not going to rewrite it. We're finding a very specific part of the cylinder. So instead of writing area of the base times the height, we are going to plug in the area of the base formula. What is the base formula for a cylinder? Pi r squared. And then still times the height. Okay, so we fill in the things we know. What is the volume? Correct. 75.36. 0.36. Equals pi times the radius. What do they call the radius? P, so I don't like it, but there it is. P squared. And then times the height, which is 6. Times 6. You're going to multiply pi times 6, so 3.14 times 6. And what do we get? 18.84 p squared. All right, all we did was multiply 3.14 times 6. So I want the letter p by itself. It means I want p squared by itself. So how do I get rid of that 18.84? You got to divide it first. Can't square root it if it's not by itself. So 18.84, dividing on both sides. So what does p squared equal? 4. So then how do I get the letter p by itself? Take the square root. What is the square root of 4? 2. So the radius is 2 inches. Is it inches, inches squared, or inches cubed? Inches. It is a length. That's that. So questions on this section? Okay. We've got one more new thing to learn, and then we kind of just review it. So go ahead and take your highlighter. Find the volume of a similar solid. Similar. Go ahead and highlight it. What does similar mean to me? Same shape. What about the size? Not just that they're different, but they are
Smaller.
starts with a P. Proportional in size. Every time you see similar, you want to think of a proportion. So think back. This is in chapter 8. We found the perimeter by taking the sides and setting them proportional to the perimeters. We did the same thing with area, where we took the sides and we set it proportional to the area. What did we do to the sides in area? We squared them. So let's put on our thinking caps. What do we think we're going to do differently for volume?
Pi.
We're going to cube it. Cube. So we're going to be using this formula, if you want to write it down. So side 1 over side 2 cubed. Volume of the first over volume of the second cubed. Here's why there's a pi. I think you're reading 45 pi. Am I right? Is that where you're getting pi from?
Yeah.
Okay. Well, when do you see pi? What shape do you normally see a pi with? Circles. So if you see a cylinder, or what's another circular 3D shape? Hopefully yeah, sphere. What's another one? You see them in the parking lot. You eat them.
Tires.
A cone. Thanks, guys. Thanks. You're going to see pi whenever you see a circular edge. Okay? So that's all that means. We'll talk about it when we get there. So let's go ahead and start plugging in. The most common mistake I see people make, especially today, is just they're not cubing it. That's like the whole point. So you're going to take a side or length, however you want to say it, from the first figure. So what is a side from the first figure? 3 centimeters. We're given a radius on the first. What is the radius of the second? 6. And it will equal the volume of the first. What is the volume of the first figure? 45 pi. So, do we know the volume of the second? No, but here's what I'm going to guarantee you. Just let's use our brain a little bit. If the first volume was in terms of pi, what do you think they want the second volume to be in?
Pi.
In terms of pi. So you are going to have pi in the answer. Something pi. That's what our goal is. Before you cube, these numbers are relatively small, but some of them are going to be very, very big. I would reduce. What is 3 over 6 reduced to? 1/2. So the common thing for people to do is reduce and then forget the cubing. We haven't cubed it yet, so you have to keep it there. And then 45 pi over v. When you cube something, what are you doing to it?
Multiplying it by itself 3 times.
Multiplying it times itself 3 times. So I'm just going to show you what it looks like. You're multiplying, so pause. You're not just plugging in your calculator. Show me how you can do it. You do 1 times, you cube the top and cube the bottom. 1 times 1 times 1 is 1. 2 times 2 times 2 is
6. 8.
It is 8. 2 times 2 is 4, times 2 is 8. You do need to be able to cube without your calculator. So all we did was cube this. Alright? So now what do we do in a proportion? Cross multiply. So let's do v times 1. That's really easy, right? Is v. But when you go the other direction, you do need to be specific as to what you type in your calculator. You're not going to type in 3.14. You're not going to type in pi. Because I want to answer in terms of pi, right? Is this number 45 pi, is it 45 centimeters exactly? No, it's 45 times 3.14. It just hasn't been multiplied times 3.14. So when you cross multiply, you're going to multiply 8 times 45, and then you'll tack the pi on at the end. You're still multiplying times the pi, you are just not typing in 3.14. Okay, what is 8 times 45? 360. So 360 pi centimeters cubed. If you do not have the pi, you are 300% wrong. Like literally, that's what that means. You're missing a lot if you miss pi. Okay, we've got 2 more things to do, and then you'll be off on your own. We're going to go back to the half sheet of paper. So this is similar to what we've been doing. It's actually a little simpler. We're going to find the area of the base. So go ahead and highlight. We're finding the area of the base of a rectangular prism with the given volume and height. Then we are going to give a possible length and width. So that's the semi-new thing, but it's not super difficult. So let's start with the volume formula of any prism. Volume equals area of the base times the height. So I told you when you're finding the area of the base, do not replace this with the formula. Just keep it a capital B. It represents the area of the base. I'm looking for the area of the base, so leave it like that. What we can do is plug in volume. What is the volume in this question? 216. Go ahead and plug in 216. I don't know the area of the base, but I want to find it. And then plug in the height. What is the height? 12. So what is the 12 doing to the area of the base? It's multiplying. So how do I solve for the area of the base? Divide. So what is the area of the base? 18, and it would be yards. It's area of the base. So is it yards squared, or yards cubed? Squared. Good. So we're not done. You can circle it. It then asks a step further. Then give a possible length and width. Think about area of a rectangle. What is the area formula for a rectangle? Length times width. It's asking what 2 numbers we could make length and width that would make 18 square yards. So what are some numbers, 2 numbers that multiply together to make 18? You're all correct. So we're going to write all of them in this case. If you're given this problem, which you are on the worksheet, you only need to write 1. We're going to list all of them because we're doing notes. So we could have said, I heard 2 yards and 9 yards. So that's one of them. Make sure you put the measurement. We're talking about a length and a width, so it's yards, not yards squared, not yards cubed. What was another?
6 times 3.
Yeah, so 6 yards and 3 yards. There is one more.
1 times 18.
1 and 18. So 1 yards and 18 yards. It's okay, Desiree. I was just letting it go. It's okay. It's okay. You get it, though. You're good. Right? You get it? You good? All right, so we're going to do it again. That was it. You would only need to list one of these on an assignment. We just listed all of them because these are our notes. All right. So, again, volume equals area of the base times the height. What is the volume in this question? 448 equals the area of the base times the height. So what is the height? Times 14. Divide by 14. It is 32. So area of the base is 32. It's inches. Is it inches or inches squared or inches cubed? Inches squared. And then we do the same thing. You give a possible length and width. So let's start very small. That's okay. 1 and 32 is what I was going for. 1 inch and 32 inches. Make sure you're putting the measurement. And then go to 2. What else is there? 2 and 16. I'm going to make these smaller. All right, and then 3 doesn't go in, but 4 does go in. 4 and 8. 5 doesn't, 6 doesn't, 7 doesn't, and you're back to 8. So sorry, they kind of bled into each other, but that's it. The only other thing that is on the worksheet, we haven't done it yet, but I gave you the easiest problem possible, and it's called a composite. If you ever hear the word composite, it's 2 things that combine into one. So there's composite bats, there's composite soil, there's a lot of composite you don't want to know about, but composite. So whenever you see, if you look at the back of the worksheet, the last question, it is number 11. There's a composite solid, the worksheet. Some people didn't get it. I'll pass it out. Composite means two shapes put together. So if we were finding, let's do area for a second. Okay, let's say I had the area of this square was 4 inches squared and the area of this triangle was 2 inches squared. What would be the composite area of this solid? 6 inches squared. Because you have the area of one, the area of the other. You add them together, you get the area of all of the solid. Are we tracking? Mm-hmm. Okay, what if, and you've done this one before, it said find the area of the shaded area. What would you do here? Find the area of both shapes. What two shapes are there? A square-ish, maybe a rectangle. A square and a circle, right? There's a square and then there's a circle. And then what would you do? Would you add them? Were they combined to each other, or was one taken away from the other? One's taken away. So what would you do once you find both the areas? Subtract them. So all it is asking, when it says find the volume of the composite solid, you have two shapes. You need to look at it and decide were two shapes added together, or were two shapes, one was subtracted from the other, one was taken away from the other. You find the volume of both, and you decide if you add them or if you subtract them. Go ahead and begin on your assignment.